the first skill is to turn an angle magnitude vector into a vector component vector. Okay? And to do that, the first thing you do is you want to find the trig angle. So step one is to find the trig angle. Okay? So if you didn't take trig, that's okay. I don't know how you're here, but that's okay. But here it is, right? These are the trig angles. 0 degrees is the x-axis. 90 degrees is straight up. 180 is straight to the left. That's the negative y or negative x-axis, right? And then negative y is 270. That's concept 0, right? Now, what they're going to do is they're going to give you some angle. And you've got to figure out what the trig angle is for that angle. So, for example, if I give you this angle right here as 37 degrees, okay? Well, you know, it's like, gee, remember the trig angles are anti-clockwise or counterclockwise from the x-axis, right? So this guy is, here's 0, here's 90, right? Here's 180, here's 270, right? So this y here is, well, it's beyond 0, it's beyond 90, right? And isn't it 37 beyond 90? That makes it 127, does it? Yeah, there we go, right? Right, is 90 plus 37. Or if I give you this guy here, let's suppose we've got a angle like this, and this guy is 43 degrees, right? The trig angle, this angle here is 90, 180. It's not all the way to 270, is it? In fact, it's 43 short of 270, which makes it, is that 227? Is it? Right? So this angle here is actually 270 minus 43, right? So you got to figure out what axis it's pinned to. If it is before it, then you subtract from that, right? It didn't all make it to 270. If we're showing after something, right, like this one, then you add it on. Yeah? Should we try some of these? Let's just see. We don't need to whiteboard these, but let's. Is that the trig angle? Yes. Yeah, it is. It's anti-clockwise or counterclockwise from the x-axis, so that is the trig angle. Okay. How about that one? Is that the trig angle? No, what is the trig angle? Well, it didn't make it to 270, did it, right? So it's 0, it's 90, it's more than 180, but it's not quite 270, it's 15 short of that, which makes it 255, yeah? Yeah? How about that? Is that the trig angle? Oh no, it's beyond 270, yes? So it's like 0, 90, 180. It's beyond 270 by 51 degrees. Is that 321? Yeah, there we go. .com. Okay. And then you just always add .com. And in fact, my cell phone lets me add .com to anything. So I just try to do that whenever I can. I'll be home soon .com. How about this one? What is this trig angle? 343 would be the orthodox trig angle, correct? Right, because all the way around is also 360, right? And it's 17 degrees short of all the way around, right? But isn't it also short of 0 by 17? Wouldn't that make it negative 17? Does negative 17 work in your calculator? Yeah, it should, right? Okay, unless you have like a bad calculator that just doesn't work, you know, for example. Then it's not going to work, right? But yeah, the negative 17 is going to work, okay? Now, once you find the trig angle for it, so let's do an example here. Okay, let's say that that's 62 degrees, okay? And let's say that this thing is 15 centimeters long, right? The next step is very simple, okay? What we have is we've got, in this case, the hypotenuse or even it's even better to say magnitude, right? Let's say magnitude cos theta in the x direction plus magnitude sine theta in the y direction. Okay, so in this case it looks like this: 15 cos 62 plus 15 sine 62. And this is in the x direction, and that's in the y direction. So take your calculator out right now, and let's make sure that we're in degrees for this. Yeah? So take your calculator, turn it on, and go mode. Yeah? So, and some calculators, like my TI-86, it's second mode. Click the mode button. See how degrees is black like that? You probably are in radians if you reset everything on your calculator. So here's how you change it. Just hit the arrow keys, go down, move till you're over degrees, hit enter, and then you can hit clear. So again, to find out whether you're in degrees, which we want to be in for this part, right? Go mode, or second mode if it's a second function, right? Go down a couple things, go over degrees, enter, clear. Here's how to test if you're in radians or not. Find the sine of 90 degrees. What is the sine of straight up? Where does the unit circle intersect the y-axis? At 1. There we go. Let's just try it. Yes. And if you get some random bizarre number, you just found the sine of 90 radians, which is 90 radians is like I don't know how many, like 15 times, or I don't know what it is, right? Yeah? What? Well, sine 90 is just some random thing. Yeah? I don't know. In fact, you can use sine as like a random number generator. Just take a big number and find the sine of it. Right? It's like random number generator between 0, -1, and +1, right? Okay. Okay, so everybody's got that. And now you're all set. I can find my components. In this case, it's 15 cos 62, right? That's my x component. And I can go 15 sine 50 or 62, right? It always bugs me not to complete that thing there. So now we've got a couple numbers here. And so I'm going to write it this way. So my x is oh, is that the right trig angle? Is that the trig angle? I blithely went on. Is 62 degrees a trig angle? No, it's definitely not, right? Yeah, there we go. So what is the trig angle? What is that? Is that 28? Yeah, there we go. I'm going to like this better, right? Okay. So change this to actually the trig angle. This, by the way, I did that on purpose. I made that mistake on purpose because this is a real common student mistake. Okay? Let's try that again. I'll show you how I caught my mistake. Does it make sense to have a y component that's much bigger than the x? Not really, right? Let me show you. Okay, so let's go 15 cos 28, right? 15 sine 28. There we go. Now I'm happier. It just switched them around, right? Because that's the way it works. So this one is 13 centimeters in the x direction with sig figs. You, by the way, almost never round these guys. And then 7.0 centimeters in the y direction. Is it conceivable that this is 13 over and that that's about 7 up? Is it? Is that conceivable? That it's 13 over and 7 up for this? Yeah, that is, because this angle here is definitely less than 45 degrees, right? Do we know the word for less than 45 degrees? What is the word that means less than 90? Acute. And what does it mean if it's less than 180? Obtuse, right? Yeah? Okay. And less than 45, do we know the word for that? Nobody does. Okay. The word for that is that it's called an adorable angle. Okay. Angles that are less than 45 degrees are adorable. Now, isn't 28 degrees an adorable